And isn't that right? Okay. Yeah, we finished 19, right? Or did we not?
Yeah, we did, because 19 was a repeat.
Oh, look at that. I know it. I got a record of it, so of course I did. Okay. All right. All right, so we're going to go on to doing two other things. We're going to look at quadratic formula, a little bit of factoring, and a few other things like that. So most of this stuff, hopefully, you've had a little bit of a background for here. Okay, so if you have something that's already factored and set equal to 0, what you kind of look at is if you had two things multiplied that were equal to 0. I mean, this is the fundamental concept. Either that's got to be 0 or that's got to be 0, right? If two numbers multiplied to give 0, one or the other one has to be a 0. Agree? Okay, it's the only way to make it possible. So what we do with this kind of a problem, if it's already factored, you don't multiply it out. You know, a lot of times students see that they FOIL. You don't want to do that. That defeats the purpose of the problem. What you do instead is you just solve each equation, okay, which is real simple to do. So you want to go ahead and solve those two equations and you'll have an answer to the problem. It's already in a factored form, so we're going to do that first of all before we get into the factoring equations we're going to do. And you're welcome to do this in your head if you want to. You're just going to add 11 to both sides, or you can just think of moving that to both sides, moving the 11 to the other side. Then you can divide by 5. So that would give your first answer really, and is going to be x equals 11 over 5. And just leave it that way. Don't use a decimal, just use a reduced fraction. Second one would be the same way. You can add 3 to both sides in your head. So that's 5x equals 3. Then you can divide both sides by 5, like that. So then you would end up getting x equals 3/5 like that. Okay, typically what we do is you have an equation with two answers, so you want to get in the habit of writing your answer like this. We call this a solution set. Okay, my math lab is going to require you to do it that way, which is not a bad thing. Okay, that's all right. So anyway, that's your answer to your problem like that then. Okay, so that's the factoring aspect of that. It's already factored, so if it's already factored, then that's what you end up doing. Okay. So one of the things that you want to do is, you know, if you kind of look at what I wrote up here, you want to make sure one side's equal to 0, and then factor would be the next thing. This one was already factored, so when we go down to 22, then it becomes a matter of factoring that then. So this is going to be dependent on how good your factoring skills are then, okay? And we've already done some factoring, so the first term is x, so we're going to go x times x to get that. Okay, the last term is going to be 45. And there's lots of possible things that multiply to give 45. There's 1 and 45. There's 3 and 15. There is 5 and 9. Which one's the right one? Right, okay. And a lot of this just kind of depends on your guys' background. 9 and 5 can be made to add up to 4. They're 4 apart. So that's how that works. So put a 5 in there, a 9 there, and it depends on your level of skill. What you're doing is you're looking at the inside term being 5x, the outside term being 9x. So the question is how do you make those two numbers add up to positive 4? One of them's got to be negative. Which one?
5.
The 5. Okay. So you're going to have a plus 9 minus 5 like that. Okay. So that means that you're going to put a plus there and a minus there in your factored. So one of the things you want to do on this, if you factored something, make sure that you've done it right. You guys can do the foiling fine. I've seen you do that all the time this semester. Now what you do is, and I don't mind if you just give me the answer to this problem in your head at this stage. Now what you're doing is you're setting each factor to 0 and then getting the two answers to the equation. So what are the two answers to these equations in your head? 5 and negative 9, right. Okay, so this is going to be x equals 5 because you would add 5 to both sides. And then this one you could subtract from both sides, so you would get negative 9. Okay, and then typically you write it as a solution set like that. Okay, now the other thing I want to mention on this too is there are times, this is actually a fairly easy problem to just sort of check in your head. So I want to just maybe check one of these answers because you can certainly do that. So if you took 5 and just plugged it in, I'm just going to draw a little box here and we'll do like check one answer just to remind you you can do that. So if x is 5, you would say 5 to the second minus 4 times 5 minus 45, and you're going to see if that's equal to 0. That's how you check the answer to any equation. So that's going to be 25 minus 20 minus 45. I think did I write something down on there wrong? Oh, that's a plus. Okay, so that's equal to 0, so that checks that answer. Okay, so don't forget that since it's an equation, you have the option to be able to go through and check that okay. All right, does the factoring look okay to everybody?
Yeah.
Okay, that's super important that you get that down. Number 23 often represents the kind of factoring problem that students have more issues with in this class. So again, we got one side equals 0. That's the first thing you check. You have a second power. It's a quadratic equation. So what we're going to do is draw our two parentheses. And then this time, the first term is actually going to have two choices. It's either going to be 2x times 2x, or it's going to be 4x times 1x. Okay, you don't know until you try, so I just teach you how to do this by trial and error. And then the last term is 7, so the only possibility on that's 1 and 7. You just have to try until you find it. Typically what I teach students to do is if the three numbers in your trinomial are relatively close to each other, then it makes a lot of sense to choose the 2 and 2 because they're closer together than the 4 and 1. Now that doesn't mean it's going to work, but it's a good place to try, okay? So let's see how this works. So let's put a 2x there, put a 2x there, and then put the 1 and 7, and then we'll just have to see if it works. If it doesn't, then we'll try something else, okay? So I try to get students to do this little visual on here. See, this is 2x. This is 14x. Okay, what are you trying to get? Negative 12x. Look at that. Is that going to work? My goodness, it is. Okay, so we were just lucky, weren't we? So what is what? Which is going to be negative and which is going to be...
The second one has to be...
Right, okay, yeah. 14's got to be negative. 2's got to be positive, right? Because 2 minus 14 is negative 12. Okay, if you take the time to draw that visual on there, then it'll help you see what the combination is that you're doing. So that means now if we're going to get the 2x to be positive, and that's positive there, if we're going to get the 2 and 7 multiplied to give negative 14, then that goes like that, okay? So that's the factoring. So a lot of times students have to work on this factoring a little bit more than what I did on number 22. Okay, so now what do you do to finish up? You set each factor to 0 and solve. Okay, so what you're going to do next is take 2x plus 1 equals 0, solve that equation, and then do 2x minus 7 equals 0 and solve that equation. You can do that in your head if you want to. That's 2x equals negative 1. Okay, divide both sides by 2. So that will give one of your answers is negative 1/2. Okay, second answer, just take the 7 to both sides. So now you'll have 2x equals 7. Divide both sides by 2. So you'll have x equals 7/2, like that. So those are your two answers. Okay, you can write it in the set builder notation if you want to. You don't have to, or you can just circle the two answers like that. Okay? All right, does everybody understand that factoring okay, you think? Okay, that's trial and error. It's a little harder, but you have the ability to go through and see if it, checks and works out. Okay, what do you think the first step on number 24 is? Exactly, set it to 0. When you see that you have an exponent of 2 or higher, the way you solve these equations, first of all, is to make sure that one side's equal to 0. So I'm going to move the 64 to this side so that I will get 8x to the second minus 64x equals 0. So that's how you must start the problems like that. You have to, okay? Now, how do you factor something like this? This is not a 2 parentheses situation. What is it?
Completing the square?
It will be. Now, I think you're seeing what you're going to see, but you take a common factor out first, right? Okay. So notice that you have an 8 and you have an x. Okay. Now, since you have an x the second and x the first, you always take the one with the lowest exponent out. That's called a common factor. So when you do that, you would have 8x, then draw a parenthesis like that. Okay. Now you can kind of complete this in your head. What do you multiply 8x by to get 8x the second? Multiply it by x. What do you multiply 8x by to get 64x? By 8. There you go. Okay, like that. Okay? Now, we're going to do exactly the same thing. What you have is you have two factors. That's a factor right there. You set that to 0. That's a factor right there. You set that to 0, then the problem's done. So we'll just do 8x equals 0. Solve that. X minus 8 equals 0. Problem done. Okay, what are the two answers in your head? 0 and 8, right? Okay, yeah, you can do that in your head. I don't mind you guys doing that in your head at the very end. So that's x equals 0 is one answer. And then you can add 8 to both sides if you want to, just to show that step. So you get 8 and 0 like that. Okay, those are your answers. Okay? All right. So go ahead and I'm going to let you guys work a little bit on 25. And then on the next page, then I guess the next 3 problems, I want you to do up to 27, and then we'll see how that goes. I'll walk around and see if you guys know what you're doing or not. What we got going on this now. So with this 25, you should have done x and x, of course. And then what did you use for the 40? 4 and 10. Good. And then the signs on that are going to go minus and minus because you want to end up with a negative 4x and negative 10x, adding up to negative 14x. So now it's just a matter of doing this. Okay, if you're doing your homework, all I really want to see is the factoring. The end of this, I would like all my students to just do in their head. So what are the two answers? 4 and 10. Just write it like that. Okay, that's it. Okay, so once you get the factoring down, then you should be in good shape then. Okay, any questions about that one with anybody? Okay, right. If you have trouble finding that combination, just write things down. Go 140, go 220, 410, 58. Just do it in a logical order like that, and eventually you should come up with something that works. Okay, you might not always see that immediately. Okay, what did you do first on 26? One side's got to be equal to 0. It doesn't matter which side, so I'm going to do this like this. Now, I'm going to do something that's a little bit different on this. I mean, you probably didn't do this because I didn't say this, but isn't it true that 9 and 54 both divide by 9? Okay, so you can take this approach if you want to. Now, you didn't have to do this, but I want to go ahead and show it that way. That's the way I always do the problems, is like that, because see, now you've got x squared minus 6x equals 0. Okay, you should have got the same answer anyway. Now what's the common factor of this expression? Just an x. So you can take x out now, then you'd be left with x minus 6, and then it's the same thing. You guys probably just had 9x times x minus 6, still gives the same thing. So you have x equals 0 when you set that factor to 0, and then x minus 6 is 0, so you get x equals 6. So your two answers are going to be 0 and 6 then, like that. Okay? Does that look okay? Okay, all right, take that approach if you want to, or just pull the 9 out. It doesn't make any difference. Okay, with this one, your first term, you have these possibilities, 3x and 3x. And if that doesn't work, you can go with 9x and 1x. For the 7, you only have 1 and 7. Okay, this is a problem that one of the reasons students don't do well on this is they think they're going to be able to do it in your head. I can't do this in my head. I have to write something on my paper. So I'm going to just start with 3x and 3x and see if it'll work. Then I'm going to put in the 1 and 7 and see if that'll work. I just try. All right, so if I look at this visual, see, that's 3x. This is 21x. What do we want to happen with those two numbers? We want them to add up to that middle term. And you can do that if you add them up, right? Okay, so if you write that visual down, it'll be pretty clear whether you're going to get it to work or not. That's just going to be two plus signs, so that's how your factoring should have went. Now, you could have those in a backwards order, obviously. You could have the 3x plus 7 first and the 3x plus 1 second. It doesn't matter. So now what you want to do is solve these two equations, and then you're done. And again, if you can do this last step in your head, just do it in your head. I want you to be able to do this in your head. So move the 1, you get 3x equals negative 1. Divide by 3, one of your answers should have been negative 1/3. Okay, and then this one, move the 7, you get 3x equals negative 7. Divide by 3, your second answer should have been x equals negative 7/3. Okay, everybody get that okay? I saw several people leaving that one blank. That's kind of typical. That's the factoring that students tend to have a little bit more trouble with, okay? So these things basically are going to be factorable quadratic equations. If they don't factor, then we have a formula. So I think most of you probably got a background for the quadratic formula. So I've written down the quadratic formula. The main idea is this is the standard form of a quadratic equation is ax squared plus bx plus c equals 0. So the quadratic formula, it turns out you can solve any quadratic equation if you put it in standard form, identify a, b, and c, and crunch out the arithmetic. Now there's going to be times when you're going to get answers that are radicals. There's going to be times when you get complex numbers that are answers too. So we're going to work a little bit on that for a few minutes to work that out then. Okay, so in this 28, this is a standard form of a quadratic equation, okay? A is going to be the number in front of x squared. B is going to be the number in front of x, which is negative 10. And then C is going to be 41 like that. So we just crunch it out, okay? This one does not factor. If you tried to factor this, you would not succeed in doing that, okay? So what we do is we just work with the quadratic formula, okay? So the first thing we do is we do negative b plus or minus square root b squared minus 4 times ac, and it's one big fraction over 2a. Now that's the way I always try to get students to set these problems up, is use parentheses where all those things go. Part of the reason for that is so that you deal with negative numbers correctly, okay? So here's how everything plugs in. The b goes in there, so it's negative b, so you do have to have that negative negative. Then under the radical is b squared, so that's negative 10. Then it's 4ac, so a is 1, c is 41, and that's all over 2a, which is 1. Students do not ever have any trouble at this level plugging in. That's not the issue. The issue usually is the very end of the problem if you have to simplify it. Okay, so what we're going to do next is just work this out, work out the arithmetic. So negative 10 is 10. Then you're going to do plus or minus, under the radical, negative 10 squared. What's negative 10 squared? That's 100, and it's positive 100, right? Because it's two negatives being multiplied. So that's 100. Okay, now you would have to take 41 times 4, which is probably 164, I'm pretty sure. So we're going to do 164 like that, okay? And then it would be all over 2 times 1 or 2 like that. Okay, and that didn't come out, that's 164 like that, okay? Everybody okay so far? Okay, this is not the hard part, this is the arithmetic part, which is usually okay for students. So now we have 10 plus or minus square root of, and that would be negative 64 all over 2. So let me write that a little bit clearer like that. Now we had a little bit of time to talk about imaginary numbers. I don't usually in this class go over that. I give you some homework to review that. So when we do the square root of negative 64, we did this just a little bit in class last time. That's an imaginary number, right? Okay. What it really is it's the same as I, which represents that it's an imaginary number, times square root of 64. So what's the square root of 64?
8.
It's 8. So what you end up having is you have 10 plus or minus, and you just write that as 8i all over 2 like that. Okay? Now, that is not done, and the reason it's not done is because notice that 10 and 2 reduce, and also 8 and 2 reduce. So you want to kind of take this in 2 directions. Just split it up like this. Okay, you can split this up in 2 parts. Now you would have 5 plus or minus 4i. Okay, and that is what we would call an abbreviated answer to the problem, like that. Now, if you wanted to write it like this is the way my math lab is going to want you to do this. They want you to just go ahead and type in the 2 answers. So these are complex numbers. One of them is 5 minus 4i. The other one is 5 plus 4i, like that, okay? So the quadratic formula, you are going to end up with complex numbers in there. That's when you have the I, you are going to encounter that issue sometimes when you do that then, okay? All right, I want to show you a little technology thing on this too. This is sort of a nice thing to teach students at this level also, is if you have your calculator with you, get that out, and I'm going to display something on here and just kind of show you that if you want to do this, you can check and verify your answer to this problem. It's actually a really cool thing to do on the calculator. What you'll find on most graphing calculators, Most of the time, if you look at your decimal point, you might see a letter I above your decimal point, do you? So if you go second decimal point, the letter I comes up, and that stands for the imaginary number. So what I'm going to do is I'm going to show you how you could check your answer to this problem for a minute here. And this is, again, a fairly nice thing to be able to do. So what I'm going to do is I'm going to take the equation that we solved, and you can try this if you want to try this. You just go parenthesis, and let's put in one of the answers. Let's put in like 5 plus 4i, and you can either write this down or you can try to do this with me if you want to, and then square it. See, what I'm doing is I'm replacing all the x's with one of the answers. So you can go 5 plus 4i squared, then you can go minus 10 times, and then put in 5 plus 4i again, put in the same answer, 5 plus 4i, okay, like that, close parentheses, then plus 41. Now this may or may not work for everybody's calculator, it depends on how it's set up. So it's supposed to turn out to be 0. So that's what I'm doing, is just plugging in one of the answers. Now if I press that, look at that. Isn't that cool? I mean, that's awesome. Okay, like if you were doing a quiz or something or homework, you can tell you're right. Okay, if you got complex number answers, just plug them in and see if they work. And that's going to be a fairly important thing that we're going to learn today when we start looking at graphs of these things. Okay, so that I is located usually on the decimal. Is that working for those of you who tried it? Okay. All right, so that's a pretty decent thing to learn how to do, I think. Okay. Okay, so are there any questions about anything on that first example? Quadratic formula. Quadratic formula solves every quadratic equation, all of them. Okay, I'm going to do a couple more and then give you a little time to practice a few of these things then. Okay. All right, what's the first thing you do on number 29? One side equal to 0. You have to do that. So you're going to move the 3x. Okay, now I'm going to put this in the right order too. Then I'm going to move the 19. And when you do that, be sure, of course, you change the signs. This would be an example of a problem that would not factor. You could not find two numbers that multiply to give 19 that add up to 3. Okay, so what we're going to do is A is 1, B is negative 3, and C is negative 19. So again, that's your A, B, C like that. Now we're going to plug into the quadratic formula. Okay, so the quadratic formula goes negative B plus or minus, and then under the radical, it's square root of B squared minus 4AC. Then it's all over one humongous fraction bar, 2A like that. Okay, so I'm just going to plug it in. Okay, and see what happens. Okay, so let's see. B goes here, negative B, B squared, so that's where the B goes. Then you have 4AC, so A goes there, negative 19 goes there, and it's all over 2A like that. Okay, that's not usually, like I said, the problem area of this. Usually the problem area on these is simplifying the very end, okay, if you have to. All right, so let's work out the arithmetic. So we're going to have 3, and then under the radical, we're going to have 9. Negative 3 squared is 9. Now, what is this going to be right here? When you do that 4AC, are you going to get a positive or negative? Positive. You got two negatives. That subtraction symbol can be thought of as a negative. So I think that is probably 76. So that's plus 76, and that's all over 2 like that. Okay. Now, work it out. We would have 3 plus or minus square root of 85 over 2. Now, all you have to really think about on this is that square root of 85. And what you look for is numbers that are perfect squares, like 4, 9, 16, 25, 36. These are all special numbers called perfect squares, and none of those go into 85. So what that tells you is that is the answer to the problem. There's going to be times when you will have to break those up a little bit, and we'll do one of those in a minute. So that's an answer, okay? Like that, you can stop there. That is the abbreviated answer, and that represents 2 answers, okay? How does that look?
Good.
Good? Okay, that one wasn't too bad. Okay, next one, again, start the same way. Move the 5x the other side. So you're going to have x squared minus 5x plus 35 equals 0. You would find, again, this one does not factor. If it doesn't factor, don't even question it. Just go immediately to the quadratic formula. So when we do this one, we're going to have A is 1, B is -5, and we're going to have C is equal to 35. So we just go directly to the quadratic formula. Okay, so it's going to be negative B plus or minus square root B squared minus 4AC, and then again all over 2A, and we'll see what kind of happens on this problem. Okay, so if I get everything plugged in and do the calculations on this, let's see, B's -5, so the B goes there and there. Then you have 4AC, so that will be 1 there, 35 there. And then you'll have 2A, so you'll have that like that. Okay, then we just need to do whatever calculation we can on the problem to finish this up then. Okay, so let's see what we have. This is going to be 5 because there's 2 negatives. This is going to be plus or minus 25. Now we got minus that, and I'm pretty sure that's probably 140.
Yep.
Okay, all over 2. Now what kind of number is going to 25 minus 140?
Negative.
It's negative, so that means you get complex number answers, right? Okay, so when we do that, next step is we're going to have 5 plus or minus, and let's see, what is that, negative 115?
Yeah.
Okay, oh, that's kind of nice. Okay, now what you have to do on this is it's a complex number, so you can think of this, anytime you see like a square root of a negative number, just write it like this. It's just I times square root of positive 115. It's the same thing. It's an imaginary number, so you want to write this answer as 5 plus or minus I radical 115 over 2. Now, the only other thing you got to even consider on this would be if any of these numbers divide into 115. I'm pretty sure none of them do. You could take your calculator and you could experiment. I don't think any of them do, so that means you are done with the problem. Like that, okay? All right, does that look okay?
Yeah.
Okay, so I've done kind of a little bit of every issue that can show up. There's one thing that'll probably show up on one of the problems you do, and I'll let you work with that a little bit then. So is there any questions about the examples I did? Okay. All right, now I'm going to let you guys do 31 and 32 and 33. Just a little bit, take a little bit of time to do those. You only have what?
I only have 31.
You don't have a 32 and 33? Okay. You don't have this?
We do, but not 32 and 33.
Okay, well, okay, write them down. How about that? Because I want you to do them. Okay? I want you to have a little bit of experience in all the little different issues that show up. So you can do 31, and then just, you know, you don't have to put it on your notes. You can do it on a piece of paper if you want to, and that's fine. Okay? So write them down. Write those two down if they're not on your packet. And you can compare answers and see if you're on the right track. I don't know if I put an answer key on these. Sometimes I do, sometimes I don't. Are you able to, are you working okay? Yeah, I got your email and everything.
Okay.
So.
No, it's
Okay.
really hard.
I'll get you set up. We can talk after class about
Okay.
what I need to help you with. Okay?
Cool. Thank you.
All right, very
Appreciate it.
good. Okay. Okay, let's go ahead and check and see what we got on this one then. So 31, let's see, you would have negative b. Yep. Negative b, so it'd be negative 14 plus or minus square root of b squared, and then minus 4ac, and then all over 2a. So you just want to see if everybody got the arithmetic and the final answer put together on this one. Okay, so this one is going to be 14 plus or minus, and let's, 14 squared is what, 256, is that right? No, that's not right. It's what? 196, that's right, thank you. 196, and then this would be 212, sorry, I'm trying to do it all in my head. 212 over 2, like that. So now this one is going to be 14 plus or minus, and then let's see, if you subtract those, that would be negative 16 over 2. Okay, so that's what you should have got. Now what's the square root of negative 16? 4i. Okay, it's an imaginary number. You know the square root of 16, so you write that as 14 plus or minus 4i over 2. Now you're not done because 14 divides by 2 and 4 divides by 2. You can do this in your head if you want to, but technically you're breaking it up into 2 parts. So you would have 7 plus or minus 2i as your answer to your problem. Okay? You can list it out twice, or you can just write it in that abbreviated form. So if you got your arithmetic done okay on that, and you should have, if you could use a calculator if you had to, then I think everybody should have got that okay. Or do we have any problem with that? Okay, all right. Let's move on to this next one, and then the next one on number 32, you're going to have x equals negative b. Then you're going to have plus or minus square root of b squared. And then 4ac, so a is going to be 3, c is going to be negative 8. And then it's going to be all over 2a, or 2 times 3, like that. Okay? So let's see what we got on this. You can use your calculator when the numbers get, fairly large on this to help you with this if you want to. Let's see, let me get that set up. Okay, so what we have is you'd have positive 23 here, plus or minus. Then underneath that radical, you can do 23 squared, okay, which is going to be a positive 529. I think I saw most of you had that. I saw a few of you mess up with this. This is 2 negatives right there. So that would be 8 times 432. That's going to be plus 96, I think, right? Okay. And then all over 6 like that. Okay. All right. So now what we're going to have is 23 plus or minus. Okay. And then if I take 529 and add 96 to it, then I'll get 625. I think that's what I saw most of you getting on that one. Now, the square root of 625 is actually 25. Okay, so if that happens, then that really means that this thing would have factored anyway. So what you would have wanted to have done on this problem is this is 23 plus or minus 25 all over 6. Okay, now go ahead and get the 2 answers. Don't leave this answer like this. Do 23 plus 25 over 6, you want to work that out. Then you want to work out 23 minus 25 over 6 and work that out. So this looks like that's going to be 48 over 6. So that's going to be 8. So that's one of your answers. Okay, then this one's going to be negative 2 over 6. And then that fraction will reduce by 2. So you should have got the other answer as negative 1/3. So the answers to that problem would be negative 1/3 and 8 like that. So since we had just no radicals or no i's in our answer, it means it would have factored anyway. Okay, so when you're solving a quadratic equation, the quadratic formula always works, but it's always worth trying to factor it first. Okay, so I think most of you got that okay. Is there any question with that? Okay, all right, let's see what we got on this, and then we'll finish up just a couple more things here. Okay, what's the first thing you do on number 33? Set it to 0. Good. Don't forget to do that, because if you do, you're going to mess up on it. So you're going to do this. Okay, so when you set this up, this time you're solving for t. So it's going to be negative b, again like that, plus or minus square root. So it's going to be b squared, and then minus 4a times c, then all over 2a. Okay, so I want to get everything set up, and let's see if we can do the arithmetic okay on this then. Okay? All right, so this is going to end up being 7 plus or minus, under the radical is going to be 49 plus 12 all over 6, like that. Okay? So now you get 7 plus or minus square root of, what is that, 61? all over 6 like that. And then the square root of 61 does not reduce or anything, so then you would be done with the problem. So is that what we got?
Yeah.
Okay. All right. So that's the quadratic formula. Any questions? Okay. All right. Now let's move down to the discriminant test. I'm going to talk just a little bit about that to finish this up. Then we'll do a break, and then we're going to do the other section today, 3.3. Okay, here's what we're going to be getting into in the next section. So you're going to notice on these problems that sometimes you get two answers, two real number answers. If you have two real number answers, you're going to have the graph is going to be a parabola. But if you have two real answers, it means that you're going to cross the x-axis twice. That's what the meaning of that is. And there are times when you could get a double root. Okay, for instance, if you were solving this quadratic equation, this is a real good example to go through. If you solved this quadratic equation right here, if you solved it by factoring, you'd have x and x, 1 and 1, 2 minus sign. Now, what would be the answer to that quadratic equation I just made up? It would be 1, right? It would just have one answer, although it would be repeated twice. We call that a repeated root. So you would end up having x equals 1, x equals 1. So that would mean that it just touches the x-axis in one place. That's all it does. So if you have two different real answers, it's going to cross two places. If it's like this, it'll cross one place. And then if you have imaginary roots or complex roots, it isn't going to cross at all. So that's what we're going to kind of look at in the next section, is being able to utilize this and see how the graphs go. Okay. Now the discriminant test, I'm just going to go over these examples to finish this up, is when you look at the quadratic formula, the discriminant is what determines how many answers you have and whether they're complex or real. And what the discriminant is it's just this little part right here. It's the b squared minus 4ac. So if you're going to do the discriminant test, let me show you what you do. The purpose of 34, 35, and 36 is not to solve these, although you could solve them. The purpose is just to tell me how many answers you have. Either you're going to have two real answers, one real answer, or two complex answers. Those are the three possibilities, which might be why I gave you three problems. So what we're going to do is on 34, A is 1, B is going to be -6, and C is going to be -7. So we're going to go ahead and work out b squared minus 4ac, and then I'll show you how you use this to figure this out now. Okay, so plug in b, so that's going to be -6 squared. Then you're going to have 4 times a times c, like that. So that's going to be 36 plus 28, and that's going to be what, 64, right? Okay. So here's how you can think about this. Really, what you're going to end up having is you would end up in the quadratic formula without going through and solving it. You would end up having this. Now, what is the square root of 64 anyway? It's 8, and then you would have -8, so you would have two answers, right? You would have to have a +8 and a -8. So it turns out if this number is positive, this is what the discriminant test says. It says if b squared minus 4ac is a positive number, meaning it's greater than 0, then that's going to tell you that it has two real roots. Okay, so all we got to do is look at that number, and because it's positive, that's going to guarantee we have two answers. Okay, you don't have to memorize that. You can figure it out. Since it's plus or minus square root of 64, it generates two answers. Okay, like that. Okay, right? Next problem, let's see. A is 1, B is -8, and C is 16. So again, we're just going to work out the discriminant, which is b squared minus 4ac. So b is going to be -8. And then we're going to have minus 4ac. So a is 1, c is 16. So this is going to give 64 minus 64. So that's going to be 0. Okay, I'll kind of keep track of these things as I go. Well, here's what you have to understand on this. If you had a quadratic formula problem and you ended up with plus or minus square root of 0, what is the square root of 0? 0. If you add 0 to a number and then subtract 0 from a number, does it make any difference? you would get the same answer. Okay, so what's going to happen on this is if you work out b squared minus 4ac, and if you get 0, that's going to allow you to conclude that there's one real root. Okay, so all you're doing is we're going to look at the three cases. If it's positive, 2 real roots. If it's 0, 1 real root. Okay, and that's because plus or minus 0 isn't going to give you 2 answers. Does that make sense? Adding 0 and subtracting 0 don't change anything. Okay, 1 plus 0 and 1 minus 0 are still 1. Okay, so that's how that goes. Okay, now let's do this 36. So 36, we got A is 1, we got B is 2, and then we got C is 4. Okay, so if we do B squared minus 4AC, we're going to have 2 squared minus 4 times 1 times 4 like this. So if you do this, you're going to have 4 minus 16, which is going to give you negative 12. Okay, now think about it this way. This is nothing more than a part of the quadratic formula. What kind of answers do you get if you do the square root of a negative number?
Imaginary.
Complex or imaginary. You think of it as complex. So that means that what you're going to get is if b squared minus 4ac is a negative number, then you can conclude that is 2 complex roots. The only time you get 1 root is if it's 0. Okay? So you want to not just kind of blindly memorize these 3 rules, you want to understand them. Okay? Those are the 3 things that are possible. If you work out b squared minus 4ac, either you get a positive, 0, or a negative, right?
Yeah.
Okay? And then that's what is going to be what you come up with. Okay, like that. So that's called the discriminant test. And that's just kind of a quick way to assess what your graph is going to look like. And we're going to learn about that a little bit in the next section. Okay? All right, any questions about discriminant test, quadratic formula, any of that stuff? Okay?